Okay, welcome back everyone. Just made a video on solving polynomials. Apparently the audio wasn't working. I'm not sure why. When I tested it immediately after it was, so I apologize. This is the file that I went through, and I'll just kind of scroll through it fairly quickly, talking about the different factoring methods. Most of this stuff should be reviewed, so hopefully it won't be too tough for you to pick up. My suggestion is anytime you do factoring, start with common factors. If there are any, you need to take them out for sure. Once you've taken out a common factor like this 4 in the first example, then look for the ability to factor further. In this case, we can't. Difference of squares is the second thing I look for, simply because it's easy to identify. I have two terms only with a minus sign between. If they are not both perfect squares, then, if there's no common factor and they're both not perfect squares, then it's not solvable. In this case, the common factor again, 4, leaves me with x squared minus 4, and then difference of squares factors where the start of the two brackets is the square root of the first term, and the square root of the second term fills the brackets, one's addition, one's subtraction. Going further, the big thing here is solving these. You want to recognize that for this whole expression to be 0, one of these three numbers that's being multiplied must be 0. Clearly the 4 cannot be 0, so that means that x plus 2 is 0, or x minus 2 is 0. And for this to be 0, solve it. X must be negative 2. For this to be 0, solve it. X must be positive 2. Okay, so there's trinomials. I call this one simple trinomial, although what I refer to as simple trinomial is usually there is an x squared by itself. This one becomes a simple trinomial after the 4 is factored out. Again, common factor first, trying to stress that. It'll be a major deal today, actually, or in this, let's say, in this unit. So once we've got the 4 out, I'm looking for two numbers. I wrote this over here. Two numbers which multiply to the negative 4 on the end and which add to the 3 in the middle. They are positive 4 and negative 1, and that's what fills my brackets. Same argument as before, the 4 can't be 0, so one of the other two must be, and solve them. Last example here, complex trinomials. That means I call that anything that doesn't have an x squared by itself at the front. And it's not obviously a common factor, simplified. So basically we're looking at, we start with the 4 times the 7, so these two numbers here and here, I'll use 0 here and here, multiply them together, get the number, sort of a key number of negative 28. So we want two numbers that multiply to negative 28 and which add to positive 12. Those two numbers are 14 and negative 2. And then I go through the process here. This is called decomposition. You may have learned other methods. Kind of a trial and error method is one that I tend to use myself. And apparently there's a box method that's just a variation of this. If you know that you've done something different but you can't remember how, ask about it and I'll see if I can do a video to explain it. I should be able to figure out whatever method you're talking about if you can explain it well enough. So then basically what we're looking at is we split the middle term into those two parts. The order in which I place them, negative 2, 14, or 14, negative 2, does not matter. I will get the same answer at the end. And then I do a common factor between the first two terms, a common factor between the second two terms. And that results in a new common factor of a bracket. And the bracket comes out here. What's left is the 2x here and the minus 1 here. As a general rule, if there is a negative in front of this number, pull the negative out. But if by chance your brackets don't match up at that point, you want the positive number instead. It should happen unless there is a negative out front perhaps as well. But just know that what we want here is the value that's going to, is the common factor that's going to give us the same bracket left over in both cases. And then solving that, the 2x plus 7 could be 0, the 2x minus 1 could be 0. Work them out like little equations. X is 1/2 or x is negative 7/2. I just sort of finished these up to show because in the next segment we're going to see something where it's going to be nice to know what those numbers were. Okay, so those are all questions that we would have seen last year and probably the year before. There's nothing really new this year other than we do deal with some cubics and quartic functions, but the factoring you do will be the same. If we have this question here, you see that there's a common factor of x. After I pull out that common factor of x, what's left is a question that looks like the ones we were already factoring. I just sort of wrote in the answer, of course, because we had just finished it, which means that in this case, x could be 0, it could be that same 3/2, it could be that 1/2. Sorry, that should be negative 3/2, shouldn't it? Yeah. So it could be negative 3/2 or it could be positive 1/2. And again, I sort of put those up because we're going to see it in the graphing in a minute. The last thing I sort of mentioned was, can't maybe see it here. When I look at this, at first glance, it looks like a question we can't solve, but you want to understand that the fact that those exponents are the x to the fourth is the square of x squared, it means that I really have the same form as I had before. Some value where the exponent here is double the exponent here. And that means I can solve it the same way. The only difference now is when I get down to my answer, I'm dealing with 2x squared to start my bracket in both cases instead of just the 2x. And that does actually change my solution because when I try to find the zeros of this first bracket, 2x squared plus 7, it turns out they don't exist. There's no value I can put in here that when I square it and multiply by 2 and add to 7 will get me to a 0 because these values are always positive. The other side, of course, I get sort of slightly messier numbers, but it does work out. So essentially, those are the two types of questions you might see today or in the next little while that aren't quite like the ones you've seen before, although really you could have seen those as well. If you have something else, something that looks like the questions we're dealing with now, where it doesn't fit into any of those categories, no difference of squares, no common factors, no simple or complex trinomials, this is a 1, 2, 3, 4 term polynomial. The only thing we can do is graph it. And so my suggestion is Desmos is probably the nicest thing for graphing. Let's just so this is the equation that I couldn't solve on the other page. When you first graph it, this is what you'll see. And what we're looking to do is find that spot right there. If I click on it, it may show up. I can't guarantee you that though. And so what I would suggest is if you simply graph the x-axis, y equals 0, when you do that, the points of intersection always show up. And you can sort of clearly click and get negative 3.57 is approximately our 0 in this case. Just to show, if you wanted to sort of go back and say, well, what about this one? Am I sure this is right? Of course, you can just graph it as well. Take out the plus 4, and that's the equation that I factored a minute ago. There's my negative 3.5, there's my 0, and there's my 0.5. Okay, so, sorry, that was fairly quick. Hopefully not too bad. The last one ran long anyway, so this is probably better. Your job for today will be basically to factor questions to solve them, and then to graph any that you can't factor, and you can use the graphing tool as a way to verify your solutions. Again, as always, ask questions, whatever you need. The complex trinomials in particular, if you've seen another way and you can't remember how to do it, ask and I'll see what I can put together. Good luck.